It's always a pleasure to come and speak and share some information. I always feel like whenever I share, I learn more than I give, and I'm sure that'll be the case tonight as well. So I'll go ahead and jump in. Quick introduction of myself and my background, I guess. So I've spent the last 23 or so years in security. Started off as a systems administrator, kind of worked into a pen testing role and AppSec. And then I've been in leadership for about the last 12 years. And during that time, I built 5 programs from scratch to scale. I got to work on some pretty interesting projects, including at AWS, and got to help build out the security program for Amazon's drone delivery project, Primaire. And so anyway, went through that process, spent that time climbing the corporate ladder. And then last year, about this time, I got to the point where I realized that I wasn't going to be able to do everything I wanted to do in the corporate world. And so I decided to go out on my own, start my own company. And so I founded Mission InfoSec about a year ago. And the mission in the Mission InfoSec is twofold. I've got one, I want to help organizations build, launch, and operate secure products. And so to do that, I've got a free newsletter that I publish. It's supposed to be weekly. I'm not very good at keeping up with that. And then I do some consulting as well. And the other part is, which I'm really passionate about, is developing the next generation of product and application security engineers and leaders. And so this kind of came from a challenge that I've seen that I'm sure you all have experienced as well. I took a SANS course a few years ago on DevSecOps, and it was great. It was really, really informative. I learned a ton, but it was like $9,000. And fortunately, my company paid for it. But I realized that, the training, most of the training out there is not affordable for self-funded learners. And so I set out to try to my goal is to create training that's like that doesn't cost you multiple thousands of dollars, right? So I'm working on generating those courses. I released one about 2 years ago called Career Hacking Quest, which is all about, how do you create a resume, how do you interview, how do you job hunt and manage your career kind of like a hacker would. And that did fairly well. And then just recently I launched DevSecOps Bootcamp, which is trying to give people who have responsibility for securing products the tools and the knowledge they need to build out the pipelines to churn out secure products through the development lifecycle. And I can share more about that at the end. And then I'm also working on a startup with a partner if I'm not doing enough, and that's in stealth mode. But it's all about making product security easier, leveraging AI and some of the more recent advancements in technology. So hopefully you'll see more about that later. Okay, so product security, I want to just kind of jump into what it is and why it exists. Product security, put succinctly, is securing products, as the name implies, but it could be a variety of things. It could be a web application, it could be a mobile application, it could be web services, APIs, that sort of thing. There could be hardware involved as well. Most of what I've done has been in the software space, but when I was working at Primaire, it was a drone, and there were custom avionics and electronics and things running on the drone that was also in the purview of product security that we had to secure, as well as all of the traditional things running in the cloud and all of that. But it's not just securing at one point and then calling it good. It's at every stage. It's the plan as you're first starting to think about the product, all the way from coding and building and testing to releasing, deploying, operating, and monitoring. So I think a good analogy is automotive safety. If there's a safety breakdown and a car crashes or something blows up or whatever, it's easy to point the finger back at the automaker and the assembly line. But safety doesn't start at the assembly line, right? It starts at the drawing board. And so it starts at the very first moment you start designing a car or an automobile. You design safety in, and then you build it per the design. You build the safety in, and then even when you've designed it and built it, you still test it to make sure it's going to run well. So I think that's similar in a lot of ways to product security. Now, the other thing that I think is worth mentioning is that sometimes people use the terms product security and application security almost interchangeably. In some ways they are, but there's a little bit of a nuance. And I want to take just a minute to explain what that is. And so product security is kind of all encompassing. It's like going back to that, design, build, test. It's everything. It's from concept to creation, to operations, and beyond. Application security is more focused on, is it built securely? Running scans and tests to make sure that it's doing what it's supposed to be doing. Whereas product security will actually work with the product managers. And as they're coming up with the business requirements documents and the product requirements, making sure that security is included in that. And so if I had to put that in an image, I would draw it like this. So product security is kind of the overall picture, and application security is the same focus, but it's kind of a narrow subset or a narrower subset, still just as important. In fact, my last product security team, we were the product security team, but I had a design team, which kind of did all of the design stuff, and then an AppSec team, which did kind of the ethical hacking, the breaking, the scanning, the testing, that sort of thing. All right, so that's kind of the product security AppSec space, but I think what's more important probably to this audience is how do GRC and product security work together? And I think this is something I'm really, really excited about. I've seen this work really well in organizations I've worked for, and there have been other times where it didn't work so well. But if you look at the goals of GRC, and certainly this isn't a exhaustive list, but some of the basics: be compliant, earn customer trust, empower the business, reduce risk, avoid breaches, communicate with the business. All of those things are product security goals as well. And so there's a lot of overlap. There's shared concerns between the two groups. And so I think understanding that there's a lot of opportunities to work together. And so here's some of the things that I've seen that are opportunities for better collaboration. One of the things that I hear most frequently from development teams is they'll come to me and they'll be like, "Hey, Chad, you've told me I've got this list of vulnerabilities that I need to patch, or that I need to roll out coding fixes for, and they're critical. So I got to do it right now. Like, this is top priority." Well, the security operations team came to me yesterday and they said, "Hey, you've got to implement logging ASAP because like this should have been done yesterday. It's top priority." And now the GRC team is coming to me and saying, "Our PCI auditors are coming next week, and you got to give that your top priority," right? So which of these three top priorities is actually my top priority? And so, coming up with a consistent message and messaging that consistently to the organization is important, because otherwise our customers, and I'm speaking specifically of like development and engineering teams at this point, but they feel like they're working with separate security teams. The product security team is telling them one thing, GRC is telling them one thing, and security operations is telling them something entirely different. And so because GRC is so central to everything that happens in a security team, I think that team is at an optimal position to be able to unify that message, make it consistent, and help the organization know what's the most important and what the priority list is. And an example of where I saw that work really well, when I was at Amazon at AWS, there was an annual planning exercise where all of the organizations would look at what they did and what they wanted to do the next year, and then they would put together their strategy, and from that would come their budget request and their headcount request. And so what the security team would do is we'd get together several months before that, and we'd come up with what's our priorities, what are our expectations for all of the other organizations to make sure that we continue to make progress and move the needle on security. And we would publish this kind of top 10 list of here's the expectations that we have of the entire organization for next year. And that gave them the opportunity to then plan for that and incorporate that in their plans, in their organization level plans, and get budget and headcount for it that they would need to fulfill those. So great example, I think, of how that unified message can lead to a much better security impact. The other thing that I think there's an opportunity for better collaboration is just the translate the security speak into business speak. And I've seen this a lot with product security engineers, folks who've worked for me. They're typically really technical. Some of them are coders by background. Some of them are pen testers by background. And then we'll come up with these, I just broke into your website, or I broke your application and I got shell on it, or whatever. And the business will be like, "Okay, so what?" And the product security folks will come away from that. The business doesn't care. They don't care that we're insecure. What are we even doing here? But that's not what they're saying. They're not saying they don't care about security. They're saying, "Help me understand why I should care about security." And so I think one of the things that I've really benefited from my interactions with my GRC partners and security teams is understanding how to translate that to what's most important to the business. Typically, the GRC team is, they're meeting with auditors, they're meeting with the financial officers, they're meeting with sometimes even the board. And so they're getting this insight. And so to be able to translate that to not just say, you know, hey, we got access to this server that we shouldn't have been able to get access to, but to be able to say, and that is a big deal because it's one hop away from all of the financials for the company, or it's one hop away from all of the credit cards for our customers or whatever. And so I think that's a really good opportunity to be able to collaborate together. All right. And then the next, what can the GRC folks get from the product security team? As I thought about this, the top three things that I saw were relationships with the development and product teams. So they are typically very deeply embedded in those organizations. In fact, when I hired people, I would tell them, I want the teams that you serve to view you as an extension of their team. And the way I measured that is when we started hearing things, when those teams would come to that member of the product security team and say, hey, we've got this thing going on. I'm kind of concerned about it. Do you want to come take a look at it? Or when they start inviting members of my team to their team activities and team building functions and such like that. So the point of that is because they've got those relationships, they know what the roles and responsibilities are. They know who's working on what. And so if you've got a concern, you need to close a finding or get somebody to work on something. Oftentimes that product security team will know who in the organization, individual or team, that you can reach out to. And they can also help translate that into what works best for them. So again, just like we were talking about with translating into business terms, you may not care about the development terms or how they do their work, but you need to get something done. And the product security team can help translate. They may come back and say, that's great. What you really need to do is open a JIRA ticket in this project, and we need to get it into the sprint backlog planning, and they're going to hold their sprint planning on this date, and we need to go, notify this person. So they can kind of help you get it in to the work stream to make sure it gets fixed. And then the second thing, security champions. So if you're not familiar with security champions is kind of like a grassroots effort to create a culture of shared security ownership across the organization. And the way that I've seen it work is you reach out to the folks in the organization who are security minded. Maybe they're just interested in it, or they've seen things go badly in the past and they want to be a part of it. And so you create a group and you give them stuff, right? Maybe you give them a T-shirt or laptop sticker, training. You hold brown bag lunch trainings type of a thing, and you cultivate that group and that relationship, and they become almost like deputized security folks scattered throughout the organization, and they can help drive things the way that you want them to go. And so if you have a security champions group, I highly recommend that you go and get involved in that. See if you can speak at one of those lunch and learns. Go in and talk about what it is that you do, what you care about. Tell them when they should come and talk to you, when they need to involve you in more complicated things. And then the final thing is to be a technical subject matter expert. If you don't have a development background or a product or application background, they can be your lifeline. You can call them in while you're going through an audit. I've gone to, toe to toe with auditors who were adamant that we were vulnerable for something, but I knew because of how it was implemented that it wasn't exploitable or that it wasn't a risk or whatever. And so those product security folks can help you fight those battles and push back appropriately when something is a bogus finding. They can also help drive remediation, which is more important, right? Next, I want to talk about how you can use automation to make your life easier. And I think this is what's really exciting, because when you understand what can happen or what you can do with automation, it's really exciting. And what's cool is, I'm going to show you an example here at the end that is going to look super technical. I'm going to break it down, but I can tell you that I didn't write that line by line. I went to ChatGPT and I was like, hey, this is what I want to do. What do I need to do to build this? And it helped me build it. And I had to do some troubleshooting. It didn't work right out of the box. In fact, when I tested it this morning, it wasn't working and I had to change some things. But this is something that you can do. And it's really cool that we have these tools at our hands. So there's a few terms that you need to understand, and Git, GitHub, and GitHub Actions. Don't worry if you don't understand some of these or any of these. I'm going to go through them, but these are the things that we're going to talk about. So Git, I think probably the easiest way to describe what Git is to describe what life was like before Git existed. Sad pandas all the way around. And if you think about it, code is, it's just text files, right? You write code in text files, and they're organized in directories. And so in the early days of programming, that's all it was. Some programmer would write code on their desktop, and they would run it. But then it got more complicated. You had two programmers working on it. Well, now what you do? Well, you put it on a file server somewhere, and you both work on the same code. But the problem is, what happens if you want to collaborate or work on the same file? So let me give you an example. Let's say there's a file that has some code in it. I go and I grab that and I start changing it. I start making my changes. And at the same time, or maybe 5 minutes later, you go and grab the same file and you start making some changes. And maybe yours is smaller. You just delete a line that's no longer needed, and you save that back to the file share. I keep on doing my changes. I finish maybe 30 minutes after you finished your changes, and I go to save mine back up. Well, now the one that's on the server is different than the one I started working on. So how do we merge those changes? The file that you deleted, does that stick, or do I overwrite that with my changes? What about the changes that I'm coming in with? Is that more important than your changes? So it gets really complicated fast, and that's just with two developers. So things like, how do we resolve those edit conflicts, which inevitably happen? And then taking a step further, what if we do something? What if we make a change that breaks the application? Can we find out who made that change and when? And can we roll back to the previous state so that we can get the application up and running quickly? And usually what happens, or what the way people would deal with this, is just kind of a hard stop. Nobody touch this file. I'm working on it. I'll let you know when I'm done. And then that developer will go and they'll do their thing, and they'll check it, they'll save it, and then they'll go to lunch and forget that everybody's waiting for them to give the all clear. And then they're like, "Hey, dude, are you still working on this? Because I need to make my changes, and it's 4:30, and like I want to get out of here." And then they remember, "Oh yeah, I was done with that before I went to lunch." So that's kind of the challenge. Code is just files. It's really hard to collaborate with multiple people. And to use an analogy, before things like Google Docs and Office 365, when you were collaborating on a document, I don't know if you all remember this, but you would like email it to people, and then I'd go through and I'd make my edits, and then I'd save it, and I'd put like version 1.1, and I'd put my initials in there, and then I'd send it off to somebody else, and they do the same thing. And that's how you got around it. Now, of course, with like Google Docs, you can all just type away on the same file. So that's kind of like Git for, Git is kind of like Google Docs for code. Okay, so actually, before does anybody know who first created Git and why? You can Google it, but anybody know off the top of their head? It's kind of a fun bit of trivia. So it was Linus Torvalds, creator of Linux. And he created it because Linux development was highly distributed, and the tools that existed at that time just weren't working. They were failing and causing all sorts of issues. So he came up with his own solution. We were talking about this before, like Chris and I, if something doesn't exist, you create it. That's kind of the hacker way. So Linus Torvalds was definitely a hacker. So Git, it is a version control system. And all that really means is it's tracking versions of files meaning the code. And so what you've got is you've got multiple environments. And so on the right there, you've got the red box, your working directory. So this is just a standard directory on your desktop. It's where you write you save those files, you do your edits, whatever, you save them there. And then when you save it, there's the next working environment is the staging area. And so you say, okay, I want to add this to the staging area. I want to add this file that I just saved to the staging area. You type git add, type in the file name, and it stages it. And so maybe there's other files that are part of this change. So you go and make the changes in those files. You add those to the staging area. Now you've got 2 or 3 files you've made some changes to, and you're like, okay, this is a nice kind of packaged set of changes. I'm going to commit this. And so you type in git commit, and you type in a little message. This is what I'm changing. I'm working on the authentication system. I changed this and that. hit enter, and that commits it to the Git repository. This is still on your computer. So the Git repository is just kind of a database of files and states, and it keeps track of everything that happens, but it's still on your computer. In fact, if you've played with Git repositories before, if you look in your Git directory or in that repository, there's a Git folder. And inside that directory, there's all sorts of stuff that Git records to keep the state and keep track of things. So it's committed to your repository. It's great, but it's still just on your computer. So the next step, that bottom green box labeled remote, that's GitHub. So you say, okay, I'm going to push all of my changes in this commit up to GitHub so that other people can see it and they can collaborate on it. And so git push, that pushes it up to GitHub. It could be some other system. GitHub is kind of the one that most people are familiar with, but it could be GitLab. It could be Azure DevOps. There's several others, but GitHub is certainly the most popular one. All right, so what's GitHub? GitHub is that remote. It's an online coding platform, and really it just allows you to collaborate. You can store code, you can manage it, manage permissions, you can collaborate on it, and it's also got a lot of other cool features like a ticketing system. It's got a project tracker. It's got a wiki documentation portal that you can use. And it's also got an automation platform, which is what we'll get to in just a minute. But sometimes it's easiest to just show. And so I'm gonna show you what GitHub looks like. So this is my GitHub account, and this repository is what I use for the labs in my course, my DevSecOps course. And so this is what it looks like. You've got folders, you've got code files, and if I go down and find one of these, let's say I look at this one right here, and this will tell me a little bit about the code. So first of all, it'll tell me the history. So I can see, when was it created, by who updated it and when, and you can actually go and see what was changed. Here, I can see I deleted this line and I added this line. Let's see, what else can I show you here? The Git blame. So remember I was telling you, can we find out who changed that line of code and when? So I can see who made those changes, when they did it, what they changed, and all of that. So that's super handy, especially if you're trying to figure out what happened and fix it, right? Okay, I also mentioned there's a issue tracker or a bug tracker. And so you can create issues just like you would in Jira or something like that. So here's one. Another thing that I do in my course is we teach how to do automated scans, and then those scans upload a scan report as a ticket or as an issue in GitHub. And so you can see it's got all of the things you would expect. You can open or you can close it, you can reassign it, all of those things. You've got projects. I haven't used this much, but you can create a project board. There's the wiki, so I can create my documentation here and go ahead here and edit this. And maybe I want to create a bullet list or whatever, and it's super easy to do. There's this security tab, which should be obviously pertinent to us, but this is where you can track security issues with your code. And so this is one of the things that I do in this course is teach how to wire up scanners, code scanners, and dynamic scanners, and open source scanners to figure out where the vulnerabilities are. And then it creates issues that you can go in and say, oh, okay, I've got this code injection vulnerability. It tells me a little bit about it and how I can remediate it, such. And then the last thing I'll show you in this Insights tab, there's this dependency graph. So one of the things that's really hot now, and it has been for a while, is software supply chain security. So here I can find out all of the different third-party components that are a part of my application. So all of these libraries are used, tells me what version it is, tells me when it was added, and it tells me, if it's got a security vulnerability associated with it. And if you've ever heard of software bill of materials, SBOM, if you do any work for US federal government, a contractor, or whatever, chances are you'll have to create a software bill of materials at some point. Here's the button, you click that, it spits out a blob of text that can then be parsed by the tools that use those. So that's GitHub kind of in a nutshell. And like I said, sometimes it's easiest to just show it because it's easier to understand what's going on if you can see it. Okay, so why would we want to use GitHub Actions? GitHub Actions is the automation component. So it's really just a way to tell GitHub what to do. And so you think about it like when you're developing an application, coding is a big part of it, but there's other parts. There's testing. So like I want to make sure that my code does what it says it's supposed to do or what I expect it to do. I also want to make sure that it needs to be deployed, right? It's not going to be running on my desktop. It's got to be running on some server somewhere in the cloud or in a data center somewhere. So I need to deploy that. I need to get all of that code built and potentially built and then copied to the server where it's going to run. So GitHub Actions allow us to do all of that stuff. It allows us to use the code, to copy it, to ship it off, to test it, to do all of those things. We can also use it for security things, which is really cool. And why would we want to use GitHub Actions? I think it's the path of least resistance when it comes to application things. A ton of people use it. There's over 100 million developers in GitHub. Over 4 million organizations use it. And there's all of these additional tools that you can use. So what I often see, going back to the product security side, oftentimes the mistake people will make is that they'll buy a fancy tool and they'll run scans and then they'll expect the developers to come to their tool and see what it produced and take actions on whatever it created. And the problem is that's not part of the developer's workflow. And so it kind of forces them into this context switch where they have to stop what they're doing. They have to go and do another tool. They have to log in and, oh, I don't remember my password and I've got to reset it. Or where's my two-factor code coming? Is it on my phone? Is it coming through Okta? Where is that coming from? And by the time they get into the portal, they're like, why was I coming here? What did I come here for? And then they get back to their code and forgot what they're doing there as well. At least that's what happens to be. And so if you can build these things into the tools and the workflows that developers naturally use, your possibility of having a successful outcome is much greater. And so that's why I love GitHub Actions. Okay, so I'm going to break down an action, and it's a workflow. And so these are recorded or built in what's called a YAML file, .yaml or .yml. You don't have to care about that. It's basically just a format and structure. And you can see a sample on the right. It's, name, whatever you're naming it. And white space matters. So you tab and make things, you want things nested just right so that all of that stuff. They're stored in a special directory in your GitHub repository in this GitHub/actions directory. And so it's right there with your code. And so the cool thing about that is that it's also version controlled. So I can see when my actions were created. I can see who changed it, who did what, and all of those things. So it's great. It's right there with the code. Okay, so I'm going to walk through this one, and hopefully you'll see that even though it looks like a bunch of gobbledygook or text on the screen, it's actually not that hard to understand once you start breaking it down. Okay, so the blue box is a workflow, and that's what we refer to as a GitHub action. It's just a workflow. And so we're giving it a name, calling this hello world, and then we're saying on. And so this is just a way to say what's going to trigger this. And if you remember, let me skip back a few slides, git push was going from your computer to GitHub. And so what we're saying here is on a push, anytime somebody pushes to our GitHub repository, we're going to run this. And then you can further specify by branch. Don't really want to get into branches too much, but just to very quickly describe it. So when you're collaborating on something, your master or main branch is production. That's usually what gets deployed out to the server. And whatever goes in there, that's live. And so you want to protect that. And so typically when you're developing something new, you'll create a new branch, just a copy of the main branch or the master branch. And then you go off and you work on that, you do your thing, and you're working on a branch in parallel, independent of the production branch. And then when you get done, you then request to merge that back into production. And there's all sorts of things that go into that. You test it, you run automation to make sure it's not going to break anything. You have other people look at it. And then once everything checks, then you merge it in, and that goes back to production. And that goes into production. Okay, so that's the workflow. The next level down is the job, and that's in the purple box. And jobs, so a workflow can have one or more jobs. This workflow has one job. We're naming it print hello world. And then we've got that runs on, and this is basically, so it's telling it what you're going to run. An action, when you run this, GitHub farms it out to a server in their cloud, and it runs it and then returns it back to you. So it's going to go out to some random virtual machine in GitHub's cloud, but we get to say, I want this to run a Linux system running Ubuntu, and I want it to be on the latest version. So that runs on is just saying, wherever this goes, it's going to be running Ubuntu Linux, and it's going to be the latest version. And then each job can have one or more steps. So the only step we have, we've named it Say Hello, and it's got that one action. And the action runs echo hello world. And so if you were to go to a Ubuntu Linux system and open up the command line and type in echo hello world and hit enter, it would come back and say hello world. And that's all that this is doing. And so if you ran this in GitHub, you would look at the log output and you would just see hello world. So it's not doing much, but this is the quintessential hello world test. Okay, so what can we do with actions? And specifically, what can we do specific to security that that we can do with GitHub Actions? One of the things that I've seen routinely is it's really hard to create an application inventory. And of course, in security, we know that you can't secure what you don't know about. So we need an application inventory. But application inventories are really hard to create. They're hard to maintain. Of course, we want to get risk information out of it so we know where our riskiest applications are and where to spend time. And so that's the problem. And usually the way people solve it is they'll go buy some expensive enterprise software that creates an asset inventory. And this is usually what it looks like. And it's usually geared towards hardware assets, laptops, desktops, phones, printers, whatever. And then they'll try to shoehorn software into this. And so maybe they'll create this form that says applications. And I've seen this before, and it's super painful. It just doesn't work. It's really hard to get the information into this. Ultimately, you need the developers to do this, and they don't want to bother with this. Like this doesn't really provide any value to their jobs. And so it's just kind of seen as this mundane work. And if you're lucky enough to get them to put all that information in there, the software moves really fast. And so it's outdated as soon as you complete it or before you complete it. And so what I started looking into was alternative ways to do this. And Mozilla, makers of Firefox, they came out with this thing called rapid risk assessments. And the idea was it needs to be quick, no more than 30 minutes to do these. It shouldn't take ideally 15 minutes, but definitely no more than 30 minutes. It needs to be super high level. The idea is ask a bunch of questions and let's see if we can decide what needs a deeper dive and trigger that. It needs to be concise, it needs to be clear, it needs to be something that is self-serviceable, like a developer should be able to open this and say, answer the questions and be done with it. And it needs to be easy to update. So Mozilla did this. It was really cool. And it's kind of this idea of it's better to get less information more frequently and have it up to date than it is to get really comprehensive information and have it be outdated. So I started asking questions like, can we treat these rapid risk assessments as code? Could we actually keep them in the repository so that we can track the status of it and how it changes over time? And if we can do that, can we use GitHub Actions to automate some of this heavy lifting and the manual work? And so I just started thinking, well, what do we have to do? Well, first of all, we'd want to see, has this person completed their rapid risk assessment? If they haven't, well, let's assign a ticket to the application owner. Has it been updated recently? Because we know software changes, so we want them to review this occasionally, whether it's 3 months or 6 months or every year or whatever. And so can we check and see if it's been updated in that time frame? And if it hasn't been, assign a ticket to the application owner. And then this last point, are there any yes responses? So the idea is ask, 10 to 15 questions that help you determine if this is something you really want to go and do a deep dive on. And so the idea is the happy path is no. If they answer no to all of the questions, then we probably don't need to be concerned with this. We're good. But if they answer yes, then we need to go dig into that. And so if there's a yes to any of the responses, well, let's assign a ticket to the security team to go and look at it. And so here's kind of what it looks like. And I'll show you a full example of this in a little bit here. It's in Markdown. If you're not familiar with Markdown, it's just kind of a way of formatting text, like, a single $ before some text means it's a H1 header. If there's 2 $ it's an H2 header. And so it's a way that you can format the text, but it's done in a way that it's parsable by code. Code and computers can look at these and make sense of them. And so the idea is, give us some metadata. Tell us, what's the name of this service? Who owns it? Is there a risk impact rating if you know it? If so, record it. And then here's a sample question. So would a breach of this service impact more than 10,000 users? So set that threshold to whatever you want. But if the answer is no, maybe we don't care. The answer is yes. Okay, now we've got something that impacts a lot of users. We should really go dig into that. The other example here, would a breach or compromise of this service impact the integrity of critical business functions such as financial reporting, customer data management, or regulatory compliance? The answer is yes. We need to know about this. This is a critical application. Okay, so this is the part where I'd like to do a demo, and I'm hoping the demo gods smile on me and that this works well. So let me show you what this looks like, or what this could look like in practice. So again, this is just the repository I used for that course. So I created this RRA, Rapid Risk Assessment.md, which stands for Markdown. So the idea is every repository could have one of these, and then all the developer has to do is go through and fill this out. And again, you can specify this however you want. The idea is keep it short, keep it simple, keep it well-defined. Somebody should be able to work through these questions in 15 to 30 minutes and answer them pretty quickly. And so you can see some things, is this going to affect our compliance certification with GDPR, PCI, or whatever? It talks about the type of data that's involved and all of that stuff. Okay, so that's what a rapid risk assessment could look like. Now, I want you to pay attention. This one was updated 4 months ago. I showed that to you earlier. So maybe we want to have that updated more frequently. Okay, so next thing, I'm going to go into the Actions tab. And here I've got all of the actions defined that I've created, the automation that I want to do. And this RRA check is the one that we're interested in. So it shows all of the runs, how many times this has been run, whether they succeeded or failed. And then I can dive into that YAML file. So let me walk through this real quickly. And I'm not going to dive into all of the details. Like I said, I didn't write this by myself. I had a lot of help with ChatGPT, which I think was awesome. But the reason I say that is because you could take this, and I highly recommend, if this is something you can use, just start with this and start tweaking it for what you need. And you could throw this into ChatGPT and say, hey, this is a GitHub action. Can you explain to me what this does? And it'll spit out a pretty succinct and understandable set of explanations for what it does and how you can change it. Okay, so I'll skip down a little bit. It does a few things. So first of all, we're checking that RA.md file for any yes answers. And if there is, then we're going to say, okay, this needs a review. We need to go ahead and review that. Second step, let's check the last modified date of that file to see if it's been updated. And here I've specified we want it to be updated every 6 months. Okay, so if those two things are true or false, so basically we're checking, is there a yes answer? If so, a review is needed. If it hasn't been updated in at least the last 6 months, a review is needed or an update is needed. And then finally, we say, okay, let's create a ticket. And so all of this code here, this basically just says, we're going to create a ticket in GitHub. We're going to assign it to the right person. And we're just going to tell this person that they need to go and update this file. Okay, so to run that, it's pretty simple. I just go here and I say, I'm going to run this. You tell it which branch you want it to run on. Remember, I told you master is kind of the production, and then there's all these feature branches. I'm going to just run it on master. And it usually, as you can see, it takes about 11 seconds to run. But this is, again, it's farming it out to GitHub machines. So sometimes it gets stuck in this queued position. Fingers crossed, it'll work and it won't get held up too long. And so you see it's spitting out all of this output. So it ran that check to see if there were any yes answers. It didn't find any, so no review needed. Next step, how long ago was it modified? And it's spitting out these timestamps, and it's checking, just doing basic math to see, is it older than it should be? No update needed. Okay, so let's make this a little bit more interesting then. Let's go and change this so that it actually does need an update. So I'm going to go back into here, and you can modify this from your desktop and push it up just like I showed in that screen before. You can also edit it directly in GitHub, which is kind of cool. So this will do kind of all of those steps condensed and then just commit it. So what I want to do is I want to go down here, and what I'm saying is 6 months ago, this is how I determined that. Well, what if, so the file is 4 months old. So let's say we want to do 3 months. And so I'm just going to change that 3 months ago. Now, if I were doing this for real, I would go and change all of these names. These are just variable names so that it makes more sense. But I'm in a hurry. Let's just say I'm just going to change that one thing. I will commit that, change frequency to 6 months to 3 months. Okay, and this is that commit message. Remember, I was telling you when you create a commit, it's going to say who did it, and you have a chance to put a message there. So I'm committing that. It's going to go off and make that change. And now I can go back in and let's rerun that. So I run the workflow again. And this time we expect it will do something differently. All right. So it ran the yes check. No review needed. We didn't change anything in the rapid risk assessment. So we expect that. But it determined, hey, this is older than 3 months old. So an update's needed. So now if I go back to my issues, now you see we've got an issue that says, hey, your rapid risk assessment file needs to be updated. And so now that developer can go out and change that. Okay, so let's also check, what if that rapid risk assessment had a yes answer in it? And I'm going to cheat a little bit here. I created a separate file, ra1.md, mainly because I don't want to touch this one because it's 4 months old. And as you see, that's kind of useful for demos. So I'm going to change this one. And as you can see, I went in and changed this one to yes. Let's say maybe this one is yes too. And we'll commit that. Updated RA, commit that. And again, what's great about that is I can now see what was changed and by whom. So at this date, this time, this question flipped from no to yes. So that's really helpful from an audit perspective to be able to see what happened. Okay, so now we need to change one more thing before that will work. Because I changed the name of the file, I also need to change my workflow file so that instead of looking for that RA1 or RA.mdm, I'm going to just change the file name. So not a big deal. I'm not even going to put a message in that. Okay, so now we can run that again. And what we expect is that that will trigger both on the 2 yeses and trigger on the fact that it's old. So let's go ahead and refresh this and we can watch that happen. It's in progress. All right. Okay. So it found the yes, says a review is needed. It also found that it's old, update is needed. So it created an issue. And if I go back there, let's see, did it update this one? It didn't. Okay. So what happened here, I forgot about this. It actually has some logic that will determine if there's already a ticket created. And if there is one, don't create another one. So I could close this and run it again and you would see, well, actually, let me just show you one that was closed previously, not that one. So in this case, it's saying a security review is required. And so in this case, we would want to assign that out to the security team or whoever's going to go and do a deep dive on it. And then this one is assigned to the actual developer or the owner of that repository. Okay, so I think that's everything I wanted to cover in the live demo. Yep, and that pretty much covers it. So I'm happy to take some questions afterwards. I'd love to connect. Here's my LinkedIn info. My website up there has a contact me form if you want to get in touch with me that way. The QR code is like the LinkedIn. Scan this code and it'll take you to my profile. And then I also wanted to share as a way of saying thank you to this community for having me. I'm starting a March cohort for my DevSecOps bootcamp. And so I'm offering a 90% off discount, which gets it down to just under $50. And so if that's something that you're interested in, love to have you join. What you'll get is all of the lessons. So there's 28 lessons currently. I'll be continuing to develop more. There's 13 hands-on labs. There's a community that you can join. And then with the cohort, I'm going to do 6 live coaching calls, Q&A sessions, talk about whatever is going on. And I'm I'm kind of limiting that to the first 30 people because I want to keep that group small enough that we can actually have a meaningful conversation. So yeah, that's the coupon code's on the page here. The sign up code is there, and that's it. So I'm happy to answer any questions. I'll turn it back over to you, Chris.